HART and fieldbus are not obsolete. Ethernet-APL is just the technical development that enables the digitalization in the field of process plants. HART, fieldbus, and Ethernet-APL have in common that they are specifically developed for deployment in the field of process plants. They are standardized internationally, which creates broad acceptance in the marketplace. Ethernet-APL combines two technologies that are proven in practice. That is Ethernet on the one hand, and the common shielded twisted pair cable on the other. Thus, the colleagues in the field of process plants are already very familiar with the installation. For Ethernet-APL, end users and suppliers are currently collaborating to develop the best possible benefits from data and convenience functionality. Ethernet-APL defines the physical layer, so it's cables, connectors, its signals and power supply, and of course explosion protection with intrinsic safety. Ethernet-APL specifies point-to-point connections only, and this means that devices in operation remain protected from manual intervention in the plant on a different device. This, of course, increases uptime of the plant and it reduces risk. Ethernet-APL has terminators built in, so users don't even have to take care of that. And one more example, just like with fieldbus, validation of intrinsic safety comes without calculation, and this reduces planning and engineering effort. We repeatedly get the question what types of protocols the switch can handle. Well, if it's Ethernet, all of them, of course. Ethernet-APL is true Ethernet, with high bandwidth and parallel communication of multiple protocols, but without the protocol. And this is a main difference to fieldbus and 4-20 with HART. Here, protocols and physical layer always belong together. Users can select gigabit or fiber optics or Wi-Fi, and now they have Ethernet-APL for the field of the process plant, so we're having one seamless Ethernet network everywhere. With parallel communication, a controller can access the device for real-time data and process control. The engineering station can access configuration and alarm data. And the end user or an installer can access manuals, diagrams, certificates via his smartphone. So everybody has immediate access to current information. And something that the specialists will like very much, in the case that troubleshooting needs a specialist, he or she can access from remote and can support their local colleagues independent of their own location. They could be in the same office, in the same plant. They may be even on a completely different continent and can still support their colleagues. Many of our users are familiar with the FieldConnect's advanced diagnostic module. It monitors the physical layer and sends alarms when attention is required. All of this functionality is now integrated into the APL field switch. So the smartphone turns into the universal diagnostic handheld. The installer can access not only device data, but also data about the quality of the installation itself. Some users say that exchanging an instrument is even easier compared to 4-20 milliamp technology, because the instrument already registers with the Ethernet network, and the installer can check that. Ethernet-APL paves the way to digitalization in the field of process plants. It is best explored with a small plant, maybe a small extension, a tank farm, a test environment, even in the laboratory. This is where you can test Ethernet-APL and all the capabilities with extremely low risk. I'm absolutely convinced that users today should try out Ethernet-APL. It is so exciting to see how many people that are extremely conservative are today exploring the possibilities of Ethernet-APL.